My name is Oleg Zhurakousky, and here's Soby. We'll introduce yourself in a second, but we're going to be talking to you about Spring Cloud Stream, specifically within the scope of Kafka and Kafka streaming. So I'll introduce myself. Again, I'm Oleg Zhurakousky. I'm a project lead for Spring Cloud Stream and Spring Cloud Function. You may have been at my presentations yesterday and the day before. And I'll let Soby introduce myself.
Hi.
Oh, he's himself?
Soby Chacko. I'm in the Spring Cloud Stream, Spring Cloud Data Flow team, primarily working in Spring Cloud Stream side of things and committing to the Kafka Streams binder and a few other things within the data flow umbrella of projects.
He's actually project lead for Spring Cloud Stream binder Kafka. So again, for those of you who have been at my presentations yesterday and the day before, the next 10 minutes may seem to be a bit repetitive, so forgive me for that. And for those who just came in, so we're going to basically cover a little bit about what Spring Cloud Stream is and the goal of the Spring Cloud Stream, and then I'll turn over to Soby and he'll start talking to you about Kafka because I don't know much about Kafka myself. So why Spring Cloud Stream? Well, why not? Right, so Spring Cloud Stream is a general purpose framework that allows you to build microservices, but a simpler way of explaining Spring Cloud Stream is that it's basically a binding framework that allows you to bind your piece of code to remote destinations exposed by your broker. So as you may have seen at my previous presentations, you write a code, for example, as a function, and by simply bringing Spring Cloud Stream as a dependency, that piece of code is going to be activated based on messages arriving to those remote destinations. So, and that's done through the binders that we provide within Spring Cloud Stream framework. So we currently support, as a Spring team, we provide you with a Kafka Rabbit, Kafka Streams binder, and then there are a lot of community binders for Solus, for Azure, for AWS and stuff. Yeah, Kinesis. So, and there's a Kinesis guy, Artyom, sitting somewhere back there. Okay. Oh, back here, front here. So anyway, again, continuing an overview of Spring Cloud Stream. So leverages a lot of the native features provided by the underlying framework, the underlying broker. So for example, I mentioned before that we have features such as partitioning and consumer groups. Brokers such as Kafka provides those features natively. Brokers such as RabbitMQ does not. But this is the additional value that Spring Cloud Stream provides because we either fall back on the native features to expose these features or implement on top of the broker to make sure that these features are kind of compatible and exposed regardless of which binder you're using. So, and of course a flexible programming model which we hope to demonstrate in a few minutes. But then again, functional or annotation-based, like with the stream listener, but we don't like that anymore. So here's kind of one view of what Spring Cloud Stream application model is. You have application core, which relies on Spring Boot, and there are additional frameworks that are involved: Spring Integration, KafkaStreams, Spring Kafka, Spring Cloud Stream. These are all kind of, if you look at Spring Cloud Stream right now, let's say within the scope of Kafka, that's pretty much what you're going to see underneath, even though sometimes, at least we try to limit the exposure of those things to you and to say, listen, you only worry about your functional code and we will take care of the rest regardless of what we're using. So we're just going to bind that code to your destinations. So the features are, as we discussed before, the type conversion. So in other words, you don't have to, even though messages are traveling in some kind of a raw format, most of the time it's just a byte array, right? But you don't have to write your code to accept byte array or to output or to send byte array. We will do that for you. So in other words, there is a concept of a type conversion that's bundled within the framework, and we support a lot of different types, but most importantly, that part of the framework is extension point, which means that if there are certain things we don't support, meaning we don't provide a message converter for that, you can implement your own and just throw it as a bean into your configuration and we'll pick it up. Support for error handling, basically BLQ. Auto provisioning of destinations. So again, as you've seen from the demos, and you may see the demo. Well, one of our demos will kind of take care of the auto provisioning, meaning that as a developer, like in production, this feature is kind of meaningless because in production you already have destinations. But when you're developing, you want to be able to have something automatically. You just want to write code, and you want to be able to have something automatically provision your destination. So we'll take care of that for you as well. Health indicators. It's a whole other topic, so we're going to skip that, and a lot of other things. So Java 8-based functional programming model. That's my favorite topic. That's probably the most important part of this year's Spring Cloud Stream, Spring Cloud Function story, because we're not deprecating Stream Listener, unfortunately. We're going to keep it because a lot of people are still using it. But if you're coming new to Spring Cloud Stream, don't use it. And if you have a chance to switch from Stream Listener to a functional programming model, you're basically going to remove some code. That's all it is. Reactive programming model support using Project Reactor. So again, functions right now, functional programming model gives you much more features because it natively supports reactive programming models. So you can now support different styles of event processing, like simple events, streaming events, and complex events, right? So, and like I said, the framework provides a notation-based programming model, but that implies Stream Listener, which, again, I'm kind of have to mention it, but would prefer not to. The tip within Spring Cloud Stream, and actually it's not even within Spring Cloud Stream. It's like I asked this question before. When you're writing code, you typically do one of three things. You're either producing data, or consuming data, or consuming and producing data. Can you think of anything else? So effectively, the Java 8 functional programming model provided you with three interfaces that you ever need: supplier, function, and consumer. And the concept of source sinks and processors, this is just the sort of a, trying to find the right word. It's the concepts that describe essentially the same thing. So source is a function, source is a supplier, processor is a consumer, and sink is source is a supplier, sink is a consumer, and the processor is a function, right? So, but again, conceptually, you can sort of mix them in your conversation because they kind of mean the same thing. So, and that's exactly the type of applications we support within Spring Cloud Stream. And yeah. So this is a fully functional, well, Spring Cloud Stream application. As you can see, there's absolutely, it's just a Spring Boot app, right? The fact that it takes the nature of a Spring Cloud Stream app is by putting auto configuration on the class path, right? So you add Spring Cloud Stream binder to the class path, which brings Spring Cloud Stream core and whatever else that needs to be brought up. And at this point of time, as I said, we're kind of embracing boot mentality at this point. We're saying, listen, if you have a configuration with a function and you brought Spring Cloud Stream into the class path, you probably want to use this function in the scope of the Spring as a message handler within the context of a Spring Cloud Stream. And again, just as with any boot message, if that was not your intention, we do provide a way to back out. Okay. Well, just an example of supplier and probably consumer, right? So again, just a plain raw Java supplier function or consumer, and we will treat it. And the interesting thing about this is that if you think about the importance, well, not importance, if you think about, like look at this piece of code and think about how much information we could extract from it. And that's important within the context of a Spring Cloud Stream because we try to limit your configuration. So let's try to kind of decipher it. So we have a function, right, which falls into the concept of a processor because it's going to have an input and it's going to have an output, right? That's a piece of information. I know the types of the input and output, right? Because if I reflectively introspect the signature of the method, that's what I'm going to get. String, string. So I know when it comes to the type conversion, when you're sending me the byte array, I know which converter to apply to convert it to string. And because I know that that's what you want, the string. And I also have the name of the function, which allows me to create, for the provisioning purposes, the binding, which is going to, in this particular case, is going to be called to uppercase dash in or out, and so on and so forth, right? And then again, you can do the mapping, and there's additional properties you can do if you want to override the default behavior. But the point is that you code this, you click run, as long as your Rabbit or Kafka, whatever binder you're using is running, everything's going to be functioning. So you don't need to do any additional configurations. And again, just in contrast to the stream listener, you would have to create a method that you think is going to be a handler. You have to annotate it with stream listener. You have to say it's going to receive the input from this channel, send output to this channel. All of a sudden, you're exposed to all these internals of the framework for absolutely no reason. It's the information we could have known ahead of time. Okay, and this is a signal for me that this is my last slide, and I'm going to remain on stage and help out Soby with his part of the presentation. But this is kind of the sort of my favorite slide because this is really how I see what Spring Cloud Stream is, because you have destination binders, right? Those take care of binding to remote destinations, and you just slide your application with the function into the binder, and it will know what to do. So again, we kept having these debates throughout the last 3 days, and I'm going to change our front page and update our documentation. Spring Cloud Stream is the binding framework that binds the piece of code that you write to destinations. That's all, right? It's not some kind of a wrapper over Spring integration, which some people presume it to be because, yeah, we're using Spring integration underneath, but that's not, in some binders, some other binders don't. So that's already kind of a broken paradigm, right? But again, Spring Cloud Stream is the binding framework to bind the piece of code to remote destination. That's it. So I'm going to turn it over to Soby. He's going to be talking now, getting deeper into the Kafka aspects, because what I was demoing was on Rabbit. So Soby is going to do it in Kafka, and
actually, I'm going to show a demo of.
Oh yeah. Process. So let's just do a quick demo of a simple function like an uppercase, but so you can see exactly what the fully functional Spring Cloud Stream application look like.
So this is what Oleg was talking about. This is a full-blown Spring Boot application, which is using Spring Cloud Stream behind the scenes. As you can see, this is a Java util function defined as a bean here. All we are doing is returning a Lambda expression from the function. So we're gonna, if you look at the POM of this project, the way it becomes a Spring Cloud Stream application is the fact that we have a Spring Cloud Stream Kafka binder on the class path. So the moment you add that into the project's POM, you're essentially making that as a Spring Cloud Stream application. So when you run it, Spring Cloud Stream infrastructure will come in and then do all the binding, do all the provisioning and all those things. So that is an important piece. So you need to include the binder dependency in your class path, in your POM. It will be automatically detected by the framework, and then everything will be provisioned for you. So at this point, it's pretty self-explanatory by looking at this code, what it's doing. So I'm just going to run it, and then we're going to, actually, by default, there are certain things going on here. If you actually look at the configuration for this project, it's pretty much empty, right? There's nothing going on there. So you might ask, okay, this is a Kafka binder-based application. Where are my topics? Where is my input topic? Where is my output topic? So there are certain opinions that Spring Cloud Stream makes here. So by default, if you have a functional bean here like this, the function's name is bean's name is to uppercase. So we expect that you have an input topic defined in the name of to uppercase dash in dash 0. So that will be your default input topic. Similarly, on the outbound side, the default output topic is to uppercase dash out 0.
But what if I have existing topic that is called input and output, and I want to bind it to that topic? What would I do?
So there are like properties that we provide in the binder as part of Spring Cloud Stream core, using which you can actually override that. So if you have a predefined topic existing out there, you can actually tell the application that, okay, use that topic instead of using the default one.
So that's what I was telling you about. So that's like, by default, we'll bind it for you and we'll create or bind if it's already exists. And that's great for early development stages or trying or demos or anything like that. But in the real life, you most likely or most definitely will have existing destinations. And at that point of time, you will provide additional configuration to say, listen, I want this function to be bound to this destination or that destination. And quickly about naming convention. Naming convention is, we were trying to come up with something very intuitive. So function name, dash in or out, that's the only two things you can have. And second dash signifies, which is not relevant for this particular topic, but, well, actually when you get to KafkaStreams, it becomes relevant, but the index, the last part of the name, signifies the index of the input or output. In other words, for single input output, makes no sense, makes no difference, I'm sorry, but for multiple input outputs, that's where it becomes relevant, because you can have to uppercase in 0, 1, 2, 3, 4, and so on.
I'm just going to run this application. It's going to start as a normal boot up. Yes, as you can see, the Kafka binder picked up all the information and it prints out all the relevant information there. So now the application is started. So now let's sum some data into the input topic, and then let's see if we can get data on the outbound side. So this is the using a utility here, Kafka Cat. So this is the producer. So we are actually sending data into the producer topic here, to uppercase dash in 0. So just going to copy the command I put there. So this is the output topic. Is that big enough? Can everybody see that? Okay. So I'm just going to send some data here. Something going on.
Did you hit enter?
I did.
Did you hit enter?
I did.
Oh.
Sorry?
Consume it. There we go.
There you go. Sorry. All right, so let's make it real time. So, all right, so.
Okay.
All right, so there is the normal Kafka binder in action. This is the pub/sub based binder. So we publish into a topic and you consume data on the other end.
Any questions so far? Say it again, please.
No, it started previously.
No, the broker
actually.
runs out there. So the question was, is the broker started with app? No, the broker, it's not like embedded Kafka. I mean, sure, for testing we use embedded Kafka, but the broker is already running. So again, pretend you're in production, you have Kafka broker or Rabbit or whatever broker running, and you're basically using that to, yeah.
All right, any other questions? Yeah.
Can you speak up? How is it going to represent what? Title? If I hear a question correctly, you're asking how is it going to convert to string or from string?
How's it creating the title for the topic?
Oh, I just explained. The name of the function, dash in or out, dash index. So The topic is, by default, if you don't define anything, it's going to use the name of the function. And there's two benefits to that. First one is obvious, it does it automatically, and it has some kind of a default thing. But the second one is because it is using function name, you can always, when you have multiple functions, multiple topics, and so on and so forth, you can always correlate which function corresponds to, especially in the early development stages, which function corresponds to which destination. All right?
All right, so question.
Oh.
Can you use this with Redis streams on board?
No.
Can you use this with Redis streams? Well, I'll answer this question differently. Yes, providing you have a binder. Yeah, we used to have a Redis binder. We don't have it anymore, but Mark Pollock actually approached me yesterday. There is another push to have a Redis binder, so that's the answer to the question. So basically, it's the binder that provides this functionality. So, does that answer? So we need a binder.
Dependency that you added in the form.
Right.
Yeah.
Exactly.
Well, not just Kafka. We said Spring Cloud Stream Binder Kafka. So if we had Spring Cloud Stream Binder Redis or Binder Foo, that's really what. So in other words, we need to implement, the binder.
So are you using Kafka-specific features like you have Kafka that?
I'm sorry, can you repeat that
Can
again?
you use Kafka-specific features?
Sure, yeah.
Like Serdis, he's going to be talking about this. Like, yeah.
Yeah, you can definitely use Kafka-specific features. I mean, that is what Oleg was mentioning before. I mean, all those things that Kafka brings to the table are abstracted behind the framework. Like, for example, Kafka gives you like native support for consumer groups, partitioning, and all those things are sort of abstracted built into the framework. So if you're using Spring Cloud Stream, you get all those Kafka benefits
Right.
By default.
And those are not implemented, like I said, look, in Rabbit, since it doesn't provide consumer groups and partitioning, we actually do some cleverness behind the scene to make it look like it does. So from your perspective, you still define the same properties, you're still using consumer groups and partitions, but internally it goes through our code. Now on the Kafka binder side, since Kafka natively provides this, we just fall back on their features, right? And then I think you may be showing it later, like the native things like Serdis, like type conversion. Kafka allows you to define native type conversion versus using our type conversion. You can actually say, there's a property you can say, don't use Spring Cloud Stream type conversion, fall back on the Kafka type conversion. So in other words, you can provide a full-blown Kafka configuration as part of your application configuration for the features that you wanted to use.
I think that's an important point. So by default, these message channel-based PubSub binders, Spring Cloud Stream does all the message conversion behind the scenes. So it does the content negotiation and then basically does the conversion. So in the case of Kafka, if you want to use like natively provided like serialization, for example, you can actually, there's a flag that the framework exposes. You can actually set that and then bypasses message conversion by the framework and let Kafka carry on with the native serialization.
Okay. All right, let's move on. So
All right.
We'll make another pause later for the questions.
All right, so at this point, we're going to segue into a different topic altogether. So up until now, we were talking about Spring Cloud Stream from a PubSub message channel-based Kafka binder. So which means that you basically get data through a Kafka topic in a consumer. You basically consume that data and do some operation, maybe using some imperative models or Project Reactor, things like that, and then you basically do the processing. So for that, a regular Kafka binder is fine. So Apache Kafka also provides, actually before we get there, let's talk about Apache Kafka in a nutshell. I don't think I need an introduction of Kafka here. I'm sure everybody's familiar with Kafka. Its benefit of Kafka, it's based on the log data structure, up and only log data structure. It provides a lot of features that many enterprises find it as attractive. So instead of writing your data into like different multiple systems, you basically use Apache Kafka as the single source of truth, basically. Your databases, your search engines, your other enterprise systems, legacy systems, everything, basically write to Kafka and then you consume from Kafka. So Kafka is very good for consumption, on the consumption side, right? And it provides a lot of other things like it comes with a producer consumer API and a KafkaStreams API. Also, it provides transactional capabilities. Recently, they also added like support for exactly one semantics. That's a big thing, right? So it's a major accomplishment. We basically briefly touched on the producer and consumer API in the previous section when we did the demo and Oleg's section. So Kafka also provides another library called KafkaStreams. If you download Apache Kafka, it comes with the distribution. So this is a stream processing library used for writing stream processing applications. For example, if you're familiar with using Flink, or Apache Flink, or Spark streaming, Beam, Apache Google Beam, things like that, it's kind of in the same ballpark. You essentially can get data as a stream of events, and then you can perform stream processing on it, and then write the data out into a destination topic or through the some downstream mechanism.
And align it to sort of the three paradigms of event processing. We have simple event processing, we have complex event processing, and somewhere in between, there's also called stream event processing. And that's really when, if you're living outside of the world of Kafka Streams, we have Project Reactor with the Flux mono type structures. But what Kafka Streams and what Soby is talking about, they provide their own native API directly into their broker, which effectively gives you the same type of constructs in the form of a K-stream, and you'll talk about the details.
So I think one big benefit of using Kafka Streams for stream processing is the fact that you don't really need a separate dedicated processing cluster. For example, if you use Apache Flink or Spark streaming, as you know, it involves its own operational issues, and you need to have a separately dedicated processing cluster. The benefit of using Kafka Streams is that if your enterprise is already tied into Apache Kafka, you don't need a separate cluster for stream processing. You can essentially write a Java application as a normal Kafka consumer, and that is your stream processing application. So from an operational standpoint, that takes away a lot of such concerns. So I see that as a big benefit of using Kafka Streams. If you're already into the Kafka world, you don't need to bring other libraries for stream processing.
So you're saying that if I have the same topics, I can choose whether I want stream processing or event processing, like simple event processing?
Yep. Yeah, absolutely. Yeah. Right. So you can use the regular Kafka binder for normal PubSub kind of processing, event processing, and then you can use Kafka Streams for stream processing type of workloads. Another thing is that using Kafka Streams, all the guarantees of Kafka that it provides is applied, like fault tolerance, the replayability, offset management, and all those things are already built in, and all those guarantees are applicable here as well. Another thing is that Kafka Streams is a per record based processing. You get a record, you get a Kafka record, you process on it, you're done with it, and get the next one. So that is the programming model that they support. But when it comes to stateful management, state management, that is the place where this library shines the most. Using regular Kafka binder, you can probably do everything that Kafka Streams does, but there's a lot of things involved, like the moment you have to maintain your state. For example, if you have to maintain things in a time window, and then you want to basically stop your application and then restart from where you left off, that immediately brings up the necessity of having to maintain state, right? You need to pull the state from somewhere. Sure, you can actually build your own state management in your system, and that makes things very complex, right? Normal application development that involves a lot of things. So this library is already providing that feature. Like the stateful state management is actually built into the library. So that is a big benefit of using it. All right, so like Oleg said, Spring Cloud Stream provides like two binders in the world of Kafka. So one is the one that we just talked about, Kafka binder, regular Kafka binder. So there is another separately dedicated binder implementation for Kafka Streams. So in that implementation, we only deal with this library. So you can actually bind, as I mentioned, Spring Cloud Stream is basically a framework for binding. It does binding and then a few additional things. So binding is at the top level. So when you use the Kafka Streams binder, it is essentially allowing it to bind to the various types that Kafka Streams exposes. So let's say that Kafka Streams exposes a type called XYZ. So Spring Cloud Stream binder will basically bind to the type, and you have that type available in your function bean so that you can actually immediately start doing processing with that. So this is the stack. It's a normal boot application, and inside it, you have Kafka Streams at the top, and then you have Kafka Streams binder comes into play, and then Kafka Streams binder in Spring Cloud Stream is essentially built on top of Spring Kafka. Spring Kafka is at the lower layer. It provides all the necessary bells and whistles for building the binder. And then, of course, it communicates with the Kafka broker. So this is the basic stack of writing a Kafka Streams application. So these are the three major types that Kafka Streams exposes. K-stream is actually you get your data as a stream of events. I don't know if you attended Mark Fisher's keynote yesterday. He was showing that the new paradigm is that you get like events, like a product update or somebody purchased something. So you get that as an event, and then you basically immediately do some operations on that. So that is represented through this K-stream type. So that is one of the major type that Kafka Streams exposes.
So would this be like an equivalent of Flux in the reactive programming model?
Exactly. Yeah,
okay.
yeah, it's pretty much like Flux, but these are two different things.
Specific to Kafka.
Yeah. Flux is basically based on reactive streams, and Kafka Streams is a completely different programming model. So that is K-stream, and then another major type is K-table. K-table is where you get the same data, but behind the scenes, you can think of it as a database table. You only get the latest update of a particular key. So in that regard, you can actually do like joins and lookups and things like that. And in the case of Kafka, you can actually run multiple instances of a consumer, right? Let's say you have one topic with 50 partitions, and you want to basically run 10 instances of a consumer. So then the way Kafka Streams is designed is that if you define your type as K-table, you only get data from a certain number of partitions. But they also expose another type called global K-table, in which you can actually get all data. For example, if you want to have all the instances to have access to, for example, a product catalog, you might want to consider something like that. One other important thing that I want to point here is that, like all the other binders that Oleg mentioned, like Kafka binder, RabbitMQ binder, Kafka Streams binder is not portable. So that's probably connecting to that Redis Streams question that you asked. So you cannot easily take this Kafka Streams binder application and then port this to a different streaming model. So this is strictly specific to Kafka Streams library and that particular technology.
It's basically a type specific, and types are defined by Kafka.
Exactly.
So it's not like an event processing model specific. Like, for example, in a pure event-based binder with function and with reactive support, you can choose which model do you want to use. Either a streaming model by defining a function as a function of Flux, or simple event processing model by defining a function as just simple types. But in this particular case, it's a specialized binder that is specific to types exposed by Kafka. So obviously, K-stream outside of Kafka means absolutely nothing.
So in stream processing, there are like various concepts. You can actually get your data as a stream. You can immediately convert that to a table. You can do vice versa. Martin Klupman's designing data-intensive application is talking about these concepts in detail. Like you get events as stream, you convert that to table, and then you get table, and then convert that to stream reply back as to stream, and so on and so forth. Some other concepts, common use cases are time-based windowing. You want to basically find out aggregates, count, and such information. You can do different kind of joins between streams and stream to table, so on and so forth. And then you can do aggregation. You can do stateless, map, and filter, those kind of operations as well using the library. But like I mentioned before, Kafka Streams provides like built-in capabilities for stateful stream processing, where as soon as you do like some window-based operations like count or aggregation, you need to basically keep that data into some state store, right? So by default, Kafka Streams uses an in-memory database called RocksDB, a disk-based database actually on in memory, RocksDB. And then you can actually, if you want, if your application is worried with the memory issues and things like that, you can bring your own state store. For example, if you want to use some other external technologies as state store, it is quite possible. But majority of the time, you might be okay with using built-in RocksDB as a state store. One other thing to note here is that when it involves state, the way Kafka guarantees fault tolerance is that when you actually publish, put something into the RocksDB or your state store, it also publishes that same information into a changelog topic in Kafka. So that way, even if you don't have access to the state store, it actually retrieves the data from your changelog Kafka topic where it actually backs up the data. So there are different ways to get around the concern of what happens if I restart my application, if I have like thousands and thousands of keys in my state store. How do I restore if my application is going to stop? It's going to stop until it basically restores the current state. Check out KafkaStreams docs. I mean, they provide a lot of options for getting around to such performance issues and things like that. From a Spring Cloud Stream angle, we provide a lot of touch points for interactively querying the state store. So once you have data in your state store, you can actually, instead of looking up your database in the other models, we basically have some repository, and then you look through that repository to pull the data from the database. So here, if you have your real-time information in your state store, you can actually get that by using an interactive query against this database. So that is another pattern that we are observing in the enterprise these days. Like if you want to build like dashboards, like real-time inventory information, real-time information about some use case out there, it's a very convenient way to build such dashboard applications and things like that. Instead of you don't have to go to the database to get the data, but rather use KafkaStreams state store to retrieve the data. All right, so the programming model is pretty much the same as what Oleg talked about before. We support both stream listener. Actually, that is the current model that is available in the currently G8 versions of Spring Cloud Stream. But in 3.0, which is going to be released pretty soon, the Kafka Streams binder is fully now aligned with the functional model. So you can essentially write your Kafka Streams application essentially as a function bean, and then you can provide your business logic as a Lambda expression, for example, and then there's your Kafka Streams application. Another thing I want to point out is that this is not a trivial library. I mean, there's a lot of things going on here. I mean, writing stream processing applications is not easy. So I don't want you to think that by using Spring Cloud Stream, your writing stream processing applications are like becoming like very easy or anything. No, there are still a lot of things involved from an application development perspective. You really need to know there's a library to.
Right. Remember how I said yesterday that from the Spring Cloud Stream and layers above, we only care about the signature of your function. What you put inside of your function, it's outside of our control. So that's the application code. That's where the mistakes can happen, and we can't do much about it other than just, rely on a error handling mechanism exposed by the framework, right? So it's not a framework to help you with the Kafka Streams, to simplify Kafka Streams like some other Spring frameworks that layer on top of some other, like Spring JDBC, for example, simplifies Java JDBC API, right? Well, this one, again, you use Kafka Stream, we just help you with connecting, activating, error handling, tab conversion, things of that nature. But what you put inside your function is you.
Yep, absolutely. Yep. So in the Kafka Streams binder, we only support either function, Java ETL function, or Java ETL function consumer. So the supplier model doesn't really fit in the Kafka Streams binder. So you can receive data from topics, multiple topics, and then produce data. So that is your function. Or you can just receive your data and take some actions on it. So that is your consumer. So those two models fit very well. And we support multiple input and output in this binder. So if you have like 2 inputs and 1 output, you can use Java's by function support. If you only have 2 inputs, just use the by consumer. Anything beyond that, this is where it probably diverges from the other binder. They use the tuples support for multi-input and output. Here, in the Kafka Streams binder, we're using a function currying support available in Java. So it's a partial functions, and then partially applying those functions in a curried.
And I want to kind of stop right here. So this is a long debate that Soby and I had, and many other people were involved in terms of how to represent functions with multiple inputs and multiple outputs. And this is again where the specifics of not only K-stream, but also the community behind the K-stream, we had to take that into account. Because, for example, when I was talking to Soby, I said, Soby, what do you think? You're the one who's interacting with the community. How do the developers today deal with like the K-stream developers, the functional developers that live in the world of Kafka, how they do it today? What's more natural for them to do a very linear tuple 2, tuple 3, or to do a currying like function that takes something and returns the function that takes something that returns the function? Because to me, personally, that may not be the most readable way of, especially once you go beyond 2, 3 outputs or 2, 3 inputs. But again, so we kind of had a lot of debates with the community and everything. So we chose for the Kafka streams, we chose the more natural support is the function currying. However, that said, we're still in the process of providing flexible programming models. So that doesn't mean that this is the only way you can do it. We will expand various different ways of how you can declare it, and then essentially you'll pick whichever way. Because as long as we can bring it internally to a canonical model where we can say, listen, for the purposes of applying the same code, we can actually allow you much more flexible signature and say, as long as we can understand that this is a 3-input, 2-output function, we can turn it into exactly how we want it to look with the post-processing during the initialization, which we've done in Spring since inception.
So when it comes to multiple outputs, Kafka Streams provides a specific way to do that. It exposes an API method called branching. So when you branch, you essentially send it to a K-stream array. So binder behind the scenes detects that and find out how many K-streams you're actually producing in that array. And then the binder provides binding for each of those outputs. So that is the only way multiple outputs is supported in the binder. Right, so this is essentially a Kafka Streams function. So you write it as a bean, and the type signature is the method return is a function, Java util function. So the first argument is your input topic. So it's a K-stream coming in, and then you're producing a K-stream. And then in the return, you provide your lambda expression. So that is a basic Kafka Streams function in a nutshell. You know what, I'm going to talk about SERDES when we do the demo, so I'm just going to skip it right now here. I mentioned interactive queries. It's an abstraction that we provide on top of the state stores that is built in Kafka Streams. If you have time, we can also demo some few things about interactive query at the end. So Kafka Streams library provides 2 different APIs. One is this higher level DSL in which you can actually chain functions in like a normal functional way. You get a K-stream and you apply a map and then the filter, then do a count, aggregate, reduce, so on and so forth. So that is the normal, pretty much looks like a reactor-based programming, that kind of style. If you don't want to do that, you can also use the low-level processor API, which is much more powerful. You can do all kinds of things in the low-level processor. It's an imperative model that you are doing there. So in the binder, it doesn't support the low-level processor out of the box, but you can actually mix high-level DSL and low-level processor. So you can use the K-stream process or K-stream transform, and that takes a supplier of processor or transformer, and then there you can actually use the low-level processor. So using the binder, the only way you can use the lower level processor is by mixing the higher level DSL and the low level processor. So Kafka Streams provides a lot of metrics as part of the basic library. So the binder provides support for some info level metrics through micrometer. So if you have micrometer in your class path, we export all the available metrics through micrometer. Then you can then take that and then use your visualization tools to export that into a dashboard and things like that. So if you include Spring Boot actuator, so think that will become as part of your application. Kafka Streams binder also support error handling. By default, Kafka Streams allows you to log the error and skip it, or log and fail. You can, by default, I think it logs and then fails, so your application crashes if there are any deserialization exceptions. Majority of the time, where errors happen in a Kafka Streams application is when you deserialize, if it cannot deserialize. But Spring Cloud Stream adds another level of deserialization handler. It's a DLQ handler. It is strictly based on the support that Spring Kafka adds. Spring Kafka provides some support for deserialization exception handler that is delegating to a DLQ, dead letter publishing recoverer. I believe that's the name of that class. So we use that class in the binder to basically send that information to DLQ if you choose. This is not an out-of-the-box feature. You have to opt into this. You have to say that, okay, I want to use this deserialization error handler. If you say that, then the binder will send any records that it failed to deserialize to that DLQ destination. The way you can send to DLQ, it can be highly configured and tuned, and you can use all kinds of producer properties and things like that there. All right, so at this point, I think I'm gonna show a Kafka Streams basic demo, and then we'll take it from there.
Any questions so far? Yes.
On the DLQ, is there a topic name that you?
By default, the DLQ will use the actual inbound topic name, .error, and the .application ID of the application. It's basically the group.
It's documented, right?
It is documented. And then you can change that if you want. If you want to change that to something else, it is perfectly possible to do so. Yeah.
Absolutely.
So
remember, we're binding. So this is the important part. This is what Soby was trying to say, and this is actually extremely important to understand. This binder kind of lives in its own world because we are binding not necessarily to a destination. We're binding. The destination in this case is the actual type exposed by the Kafka. So it's a highly specialized binder. No.
No, it cannot. Yeah. That's an interesting use case, though, if you can somehow combine.
Sure, but I mean, the real question is why? Like, I mean, at the moment, it's rhetorical whether there is actual use case, because it's like, will K-stream guys embrace it or not? You know, like, yes, having a uniform programming model obviously has values, but then again, Flux only gives you kind of an equivalent to the K-stream, but Soby mentioned there is other two types, the K-table and global K-table, and there is no equivalent to that in Reactor API, as far as I understand. I may be wrong. So, yeah.
Yeah, so this is the dependency that you have to bring Spring Cloud Stream Binder Kafka Streams. So that essentially gives the signal that this is a Kafka Streams application. So, this is that bean that we saw before. So here, this is a function bean. Input is a case stream of strings, and the output is a custom domain. So the binder will do all the deserialization and serialization on the edges. So by that I mean that when you receive data, when you're consuming data from the input topic, the binder will do a lot of inference, and then it will infer the right SERDI to you. SERDI is actually an abstraction on top of deserializer and serializer that Kafka provides. So if you look at the SERDI interface, you can see that all it provides is a serializer and deserializer. So binder will detect that type, a string, and then it will automatically delegate to a string SERDI. Similarly, on the outbound side, we are producing a case stream of word counts in this case. So this is by the way, this is the canonical word count example that Confluent provides. So in this case, it actually looks at that type, and it realizes that it's not one of the out-of-the-box SERDES that KafkaStreams provides. So then it defaults to a JSON SERDE that is provided by Spring Kafka. So Spring Kafka provides its own JSON SERDE, so it defaults that. So in that case, it has to be a JSON-friendly object, which is in this case. So let's look at this code. I mean, as I said before, all it's doing is it's returning a Lambda expression from the method. So it's a full-blown Kafka Streams application. So normally, when you write a Kafka Streams application, you have to write a lot of, setup step. Like you have to actually, build your streams builder. You have to, set the configuration properties in the code, and then you have to start the Kafka Streams object and then maintain its lifecycle and all those things.
So
all those things
Kstream handles all this. Kafka Streams binder handles all that for you, leaving you only with worrying about the actual functional code.
Business logic. Yep.
Okay.
Exactly. So the value add here is that the application developer can simply focus on the business logic, what really matters here. So in this case, this is that high-level DSL that I mentioned before. Gets the input, and it does a flat map on that, and then does a map, and then group by the key, and then we want to find out the count of each word that occur within a 30 seconds window, and then we are sending the data back to the output topic.
And while Soby described what this code does, it's absolutely irrelevant what it does, because again, that's the code you write. We, from the binder, from the framework perspective, only want to make sure that you provide us with enough information to properly invoke this code and to properly deal with the output that you produce.
So this is the configuration for this application. So this is what we were talking about before. By default, the input binding is named as process-in-0. Okay. But I want to use a different topic instead of that default topic. So I want to consume from the topic words and then produce to a topic named counts. So this is how we can actually override that. So the documentation provides all the details of all the other configurations that you can set for this application. So let me run this, and then we'll take it from there.
While he's setting up, you guys have any questions?
So it prints out all the topology as you start. Yeah.
Okay.
Right. So the application is started. Now let me look at my cheat sheet here. I don't want to make the same mistake last time. All right. Okay. Oops, sorry. All right. Yes, as you can see, as I type this, it actually prints out the word count of that particular word. So as you can see on the right-hand side, we are consuming from the output topic in this, using that utility. So you can see that the count is increasing. So it's a quick demo of this application. So essentially what's happening is that you're sending the data to the inbound topic, do the stream processing, and then write to the output topic. Some quick notes about state management. So this looks like a very simple application, but it demonstrates a lot of concepts from a stateful angle. The moment you introduce like windows and counts on line 49 and 50, so that involves state. So Kafka Streams behind the scenes store that information into a state store. So this is not a stateless application. It's actually a completely stateful application that we are looking at here. So I just want to show how we can get the metrics that Kafka Streams provide. So I have Spring Boot actuator on the class path, so I enable metrics endpoint. So I want to first see what are all the metrics available through micrometer. So I can use this endpoint. Sorry. So these are all the available metrics that Kafka Streams provides. So if I want to just get some particular metrics, let's say that I want to see my current commit total by the stream thread. So I can actually do that. just get that. So it will give me like now so far 18 commits occurred in this consumer application, so on and so forth. So that is one demo. I have one more demo. So
And you have 5 minutes.
Yeah, we'll try to make it real quick. So the use case is this. This is also again taken from a Confluence example. So basically, you have like this in the era of social media and all. People want to be. Let's say that you have users in like different continents and all, and if some companies want to track where the clicks occurring from, so the click impression. So that is the use case you have. So here's another thing that I forgot to mention. So in those kind of instances, so you have. Let me first show you the code, and then we'll talk. So this is an example of by function. So essentially, let me stop it. The previous one. Essentially, you have two inputs and one output. So the first input is actually a stream. So the stream is basically click information. So you have users. Users are clicking some websites or some links and things like that. And then you have a K table. K table is where you get the user's information, like which continent is that user is from. So normally, this is where things like CDC comes into play. So Christian somewhere here. So you have like information coming from a database. You want to bring that information to a Kafka topic. You most likely you'll use something like a CDC mechanism to bring that data. And then once you have that data coming out from a database, then you get into this Kafka Streams application as a K table. So here you have two kinds of bindings happening here. You have K stream binding and K table binding. Once you have that data, you are doing some joins here. So you have stream coming, you have clicks information coming. Region information coming. And then you're doing a left join on that stream with the table. And then you're doing some normal map operation. And finally, what you're doing is that you are essentially finding out how many clicks are occurring from a particular continent. So that is the normal use case. So here, we are providing some convenient consumers. So this application has like multiple function beans here. One is a by function, and the other one is the consumer. So the consumer, all it's doing is it's basically logging from the outbound topic, like how many clicks are there. Then I also provided an interactive query, so you can actually interactively query that state store. So this reduce is actually putting that data into a state store. So if you don't have time today, we won't probably demo that, but we'll provide the links to how to get to the sample and things like that. You can actually run it on your own. But we're going to run the very basic use case here. So here again, I want to look at my README. So this sample has all the README information. So first, I want to send information for a user called Alice. So actually, I have to run the application first. So let me run the application.
Guys, right at the end, I have plane vacation in 1 hour, so I need to bail. But if you have any more questions, Soby is the better candidate for Kafka questions. So thank you very much. Wait a second, Soby's still doing the demo.
All I need is just 1 minute. 1 minute, okay? So I'm just going to run a producer here. Thank you, Oleg. Thank you. You know what? I'm going to post the links to this sample so that you can actually run it on your own. So in the slide deck, I think we are running out of time. So here, it's all the resources that I used for this demo is in this samples repository. So feel free to catch that there. And then we provide like detailed README there on how to run these applications. Thank you very much. If you have any questions, I'm more than happy to answer.